Okay, so in a famous experiment, Matthew Messelson and Franklin Stahl grew E. coli cells in a medium containing only the heavy isotope of nitrogen. This is a form of isotopic labeling, by the way, which is the 15N. And by the way, this is a great technique for biochemistry. You're going to see this a lot because you can get an isotopically labeled substance, introduce it, and then you can look at it with NMR, right? And the other one, you get like a 1% feedback from the rest, and so that's basically nothing. Background. These cells are then transferred to a medium with the light isotope of nitrogen, which is 14N. The result of the experiment supported the hypothesis of semi-conservative replication, which was proposed by Watson and Crick. Interesting side note to Watson and Crick is that everybody knows them for coming up with the structure of DNA, but that's actually wrong. So they got a Nobel Prize for that, but they actually stole the data from two women that worked near them. Yeah, and the person that actually came up with the theoretical structure was Linus Pauling, which is like in my pedigree. That's one of the people in my pedigree. And he's the guy that said you should always use a model. But Watson and Crick did do some really good work with DNA. And this is one of those things that they were doing. They're part of. So, they deserve a Nobel Prize. It's for the wrong thing. Anyways, so heavy DNA, 15N DNA, hybrid DNA, and light DNA, which would be the 14N DNA, can be separated by centrifugation. If cells contain 15 DNA or transferred to a medium with only 14N DNA, nitrogen as a nitrogen source, what percent of daughter molecules will be composed of hybrid DNA after 2 generations? Okay, so how does a DNA replicate? Mm-hmm. So it's going to split, and you're going to code new daughter strands for both sides, right? So every time you replicate, how much of your DNA is going to be exchanged? How much new DNA will you get?
Semi-conservative, so one part stay and one part new.
Exactly. So 50% of it will always be the new stuff, right? Okay. So every time you replicate a DNA, every generation, you'll have 50% new, 50% old, right? Okay, so we took these cells, and they originally had 15N DNA. We put it in something that the only nitrogen source is now 14N. Okay? So the new stuff's going to start being 14N, isn't it? Okay. So what percentage of the daughter molecules are going to be composed of hybrid DNA after 2 generations? Okay, so go ahead. Okay, so what's going to happen is after 2 generations, you're going to have 4 duplex DNA molecules, right? Okay, and where you're going off is you need to read the question really carefully. Okay, you're right on the amount of daughter helices, but your problem is that the question's actually asking for something that's not really a standard thought. Okay? So it's the daughter molecules are composed of hybrid DNA only, right? So the first generation, you're going to have 2 hybrids, right? 50% of it is going to be the whole thing's going to be hybrid, right? Because there'll be a daughter and there'll be a parent. Both sides have that. The second generation, though, is where you're going to get daughter and daughters, right? So when you split one of those, it's going to give you a first-gen daughter, second-gen daughter matched, okay? And that's not hybrid, is it? No. And then when you'll also get a parent, and then the second-gen daughter, right? And so 50% of that is going to end up being hybrid. 50% will be daughters only, right? And so thus not hybrid. Does that make sense? Mm-hmm. Was that clear? Okay. Sometimes I finish this and I'm like, was I even clear English-wise? Okay. Hopefully that's in English. I don't even. Oh man. Okay. Do you want to do the next part? Okay. So predict what percentage of daughter molecules will be composed of hybrid DNA if the DNA exhibited conservative replication. That is, if a daughter molecule were composed of newly synthesized DNA only. Okay. So if you just made replications and the whole things were new, right? Then you would only ever have one parent, wouldn't you? Because your parent, the 15 DNA, is it okay I'm using parent for the 15 DNA? Okay, it's not really the true meaning, but okay. The 15 DNA, the parent will never ever split, right? If it's fully conserved. And so however many generations you get, that increases the denominator, but never changes the numerator. You only ever have one, right? And so the first generation would give you 2 molecules. So it would be 1 out of 2. The second generation is going to double that bottom number and give you 4, right? And so that would be 1 out of 4. Does that make sense? And you'll never get any hybrids, right? Because it'll never split. Did that make sense? Okay. I just wanted to point out that you double the bottom denominator every time you do these. By the way, you stop increasing the numerator after the first generation for this up here, the hybrids. For semi-conservative. Conservative. It's getting political. There's a problem. Uh-oh.